हेडफोन चालू नाही व्यवस्थित. इथं बसून करणार गौरी, गायत्री, am I audible to you?
आवाज येतोय बट
गौरी काय
येतो ना आवाज.
येतोय ना?
हो
गायत्री,
मॅम येतोय.
okay, no problem. So we'll continue now. So our next point is the, आता व्यवस्थित क्लिअर येत असेल ना?
हो.
Next point is the vertical geometrical irregularities. Okay, तर vertical geometrical irregularities मध्ये बघा या ठिकाणी काय दिलेलं आहे. If there is a irregularities in the structure in vertical direction, story to story ची हाईट आहे ती जर व्हेरी झाली तर त्या ठिकाणी काय होणार आहे, देअर शुड बी अ इक्वली डिस्ट्रीब्युशन होणार नाही. लोडच असेल ओके, तर त्या ठिकाणी मास डिस्ट्रीब्युशन आहे ते इक्वली होणार नाहीये. त्या ठिकाणी काय होणार आहे, अदर इरेग्युलॅरिटीज ज्या आहेत तर त्या इरेग्युलॅरिटीमुळे काय होऊ शकतं, डायनामिक लोड जर स्ट्रक्चर वरती आला तर त्यावेळेला बिल्डिंग कोलॅप्स होऊ शकते. विंड प्रेशर मध्ये स्वे नॉन स्वे टाइपचे जे पॅरामीटर्स आहेत ते या बिल्डिंग मध्ये ऍड होऊ शकतात. सो फॉर दॅट पर्पज वी शुड टेक केअर while planning the building in vertical direction. जे काही व्हर्टिकल इरेग्युलॅरिटीज ज्या आहेत त्या व्हर्टिकल रेग्युलॅरिटीज आपल्याला काय केल्या पाहिजेत, फॉलो केल्या पाहिजेत. ओके, so that is all about the geometrical irregularities in the vertical direction. So you can see here A, B, C, D, E, F. These are the stories which are in the vertical direction are shown here, and base dimension which is shown as a A. So you can see this A is greater than 1.3 B. So that parameter should be followed by the story. जे काही स्टोरी आहे तर त्यांनी हा जो पॅरामीटर कन्सेप्ट जे दिलेले या ठिकाणी, that should be A is greater than 1.3 B. Okay, that should be followed by the building. Okay, that is the A is the base dimension here. These are the whole stories, and this story should be height should be, that is the A base dimension should be greater than 1.3 B. That is the dimension is from here to this dimension is here. So that dimension and that dimension. Okay, again there should be a second point. All the depths, whatever the height for A, B, C, D, and F, that should be same for all. The geometric irregularities exist when the horizontal dimensions of the lateral force resisting system in any story is more than 130% of an adjacent story. बघा या ठिकाणी irregularity जर असतील तर how much percentage of there is a force is resisting, किती lateral force create होते बघा, that is about the 130%. So we should take care for this vertical irregularity or vertical regularity in the structure should be followed. Okay, if you have completed, we should move towards the next slide. Next one is the in plane discontinuity in the vertical elements resisting lateral force. You can see from the plan only, from this figure only you will understand. Aishwarya Ingre. You can understand from the plan only. There is a plan. You can see this is a plan in the vertical direction which is shown. There is a B. B is greater than A. You can see whatever the column positions are here that are not in vertical in alignment. You can see the alignment which it changes. So that is also not good. That is showing the discontinuity in the vertical element. The one column is a column that A to B and B onwards, that element which having the discontinuity about the column. So that should be avoided from the structures. And if such a types of the columns are over there, then what will be happen? There will be some reflex will be produced into the building, and such a buildings will not resist the loads, or they are becomes weak while the dynamic loads are coming on the structure. So offsets, whatever the offsets in the building, and in plane, offsets of the lateral force resisting elements greater than the length of those elements. Please write down this or draw the diagram. If you are completed, we'll move towards the next point. Aishwarya, Prachi. Okay. So next point is the what you do. Only you write the point and draw the figure. Next point is the B point. Plan irregularities. You write plan irregularities. From that point number 1, you write torsional irregularity and draw the figure only. Don't write whatever written here. Just you write the point and draw the figure. So you will understand the torsional irregularity. Whatever the points we have discussed earlier, that all for the vertical irregularities. Now the B point, which is for the plan irregularities, mean in horizontal direction. Okay, in that torsional irregularity will form. Okay, what is the torsional? Torsional किंवा twisting कधी कधी फॉर्म होतो इन हॉरिझॉन्टल डिरेक्शन. जर आपल्या बिल्डिंग ज्या आहेत तर त्या बिल्डिंग रेक्टँग्युलर सेक्शनच्या जास्त असतील, त्याची जर जे काही लेंथ आहे तर ती लेंथ जर जास्त असेल त्या ठिकाणी, ओके, आणि व्हर्टिकल इलेव्हेशन जर कमी असेल तर त्या ठिकाणी काय होऊ शकतं की विंड प्रेशर असेल किंवा त्या ठिकाणी काय होणार आहे टॉर्शनल टाइपचे इफेक्ट जे आहेत तर ते स्ट्रक्चर वरती तुम्हाला जास्त प्रमाणामध्ये दिसून येतात. दॅट इज द टॉर्शनल इरेग्युलॅरिटीज. Okay, this is torsional irregularity is to be considered to exist when the maximum story drift computed with the design eccentrically. Okay, एखादं जर स्ट्रक्चर असेल, आपण जे इसेंट्रिकल जर डिझाईन करत असेल तर त्यावेळेला आपल्याला हे टॉर्शनल इरेग्युलरिटी टाइपचे जे इफेक्ट आहेत ते आपल्याला स्ट्रक्चर मध्ये दिसून येतात. ऍट द वन एंड ऑफ द स्ट्रक्चर transverse to an axis is more than 1.2 times the average of the story drift at the two end of the axis. Means at the center जे आहे तर त्या ठिकाणी जर आपण जे काही लोड आहे तो पूर्ण डिस्ट्रीब्यूट होतो असं अज्युम न करता जर इसेंट्रिकल स्ट्रक्चर जर आपण अज्युम केलं, आपण जर स्ट्रक्चर बिल्ड केलं तर त्या ठिकाणी such a types of the deflects will be produced into the building like a torsional irregularity. So we should avoid such a types of the torsional irregularity in the building for achieving the building as a earthquake resistant building. If we are completed, we can move forward. Okay. So torsional irregularity. Please write Gayatri and Gauri.
हो मॅम लिहिलं.
Okay. Point by point, you write. Okay. At least whatever point we have discussed here, that should be in your notebook. Is it okay? Shivani? Next point is the re-entrant corners. Shivani झालं? Huh? Okay. So next point is the re-entrant corner. So you understand here from this figure only, this is a re-entrant corner. You can see this X and Y, these are the vertical and horizontal, these are the base dimension. But that A and B which are shown here, these are the re-entrant corners. They are taken from this basic plan. And you can see here, these are the projections over here. This is A and B. So how much that projection should be? So that projection should be that A is equal to किती बघा या ठिकाणी that should be A is greater than 0.15x. Okay, there is a rule for this re-entrant corner. If you not assume such a rules, then that will be making the effect for the structure. So you can see here, this is a projection A is greater than 0.15x. This is the x in the, this is the in horizontal direction, that is as a length. Y is in the, in terms of the width. You can see this x, that x will be here, that A is here, it is taken as 0.15x, and y is the B is taken as 0.15y. So that is the rule for this. Okay, for the removing whatever the from both the projections of the structure, and that re-entrant corner are greater than 15th percentage of the planned dimension of the structure in the given direction. तर हा जो प्लॅनचं डिरेक्शन दिलेला आहे, तर या प्लॅन मधून आपल्याला जर रिएंट्रंट कॉर्नर करायचे असतील तर दॅट रिएंट्रंट कॉर्नर शुड बी लाईक दिस विथ रिस्पेक्ट टू द लेंथ अँड विथ रिस्पेक्ट टू द विड्थ. तर विथ रिस्पेक्ट टू द लेंथ असेल तर दॅट पॅरामीटर शुड बी दॅट विड्थ शुड बी, इट शुड बी कॉर्नरची जी काय विड्थ आहे it should be less than 0.15 of that width and with that of length, and x आणि y या ठिकाणी तुम्हाला दिसू शकेल बघा, या ठिकाणी कळेल तुम्हाला from this figure whatever the x value, whatever the y value, based on this they have given here that value should be less than 0.15x and 0.15y. So you will understand from this figure only. So that projection of the corners, re-entrant corners should be like this with respect to this rule as a 0.15 means 15% of the planned dimension. And if these type of the projections are more than this, they will be making effect for the structure, and that will become as a irregularity in the plan for the structure. Have you completed Gayatri, Gauri, Suhas?
Yes, ma'am. Completed.
Okay. Completed? Shivani completed. Okay, next point is the discontinuity into the cross-section area. So you can see here, this is a cross-section which is provided here. And if we provide this such a types of the opening, if that openings are more, then automatically wind pressure will be act here. Again, twisting will be produced. Some of the torsional effect will be produced. Okay, so for that purpose, as per the design philosophy artifact, so we should provide the opening for the building, for the doors, for the windows. That opening should be in a opening should be followed by the IS codes. Okay, if these openings are more, then automatically it will be come under the discontinuity in the building. And so for that purpose, we should follow the rules for that, for the openings for the doors and openings for the windows. किंवा काही ठिकाणी काय असतं बिल्डिंग मध्ये एका स्टोरीला ओपनिंग जास्त असतं, एका स्टोरीला ओपनिंग कमी असतं. मीन्स अनइवन क्लोज्ड एरिया, एनक्लोज्ड एरिया जर बिल्डिंग मध्ये असेल तर दॅट विल ऑल्सो मेकिंग ऍज अ डिस्कंटिन्युटी इन द स्ट्रक्चर. You write the rigid stop. Now you write This is rigid, this is flexible, this is open, this is opening, and vertical component of seismic resisting system. Open space. The last point from this plan irregularities is remaining, that is a non-parallel systems. Completed. Okay, last point, which is the non-parallel system. The vertical element resisting the lateral force are not parallel to or symmetric about the major orthogonal axis or the lateral force resisting element. बघा आता vertical element जी vertical story आहे त्या ठिकाणी vertical irregularities आणि horizontal irregularities यामध्ये जर नॉन पॅरलल सिस्टीम असेल तर त्यामध्ये बघा इन्क्लाइन लाईन दाखवलेली आहे, हॉरिझॉन्टल कॉम्पोनंट आहे आणि इन्क्लाइन लाईन दाखवलेली आहे. मीन्स नॉन पॅरलल सिस्टीम असेल तर दॅट इज ऑल्सो बिकम वन ऑफ द इरेग्युलॅरिटी इन द स्ट्रक्चर. That horizontal and vertical, both these regularities should be in an orthogonal position. If not followed, that will become one of the irregularity for the structure. Write down this also. Gauri, Suhas.
Yes, ma'am.
Yes, madam.
Okay. In the diagram, there is shown as the walls, which are the maybe shear walls, and there is a plan, building plan, which is written over there. Completed. Okay, in this way we have studied about the irregularities in the plan, in the horizontal and in the vertical direction that we have studied. Now we have to move for the next point, that is about the philosophy of earthquake resistant design. Okay, if you have completed this, we'll move towards the next point. ओके, आताच्या लेक्चरला आपण काय बघितलं तर वी हॅव सीन द इफेक्ट ऑफ इरेग्युलॅरिटीज इन द स्ट्रक्चर in the horizontal and in the vertical direction. Okay, the horizontal and vertical direction, there should be a we should avoid the irregularities in the vertical, that is about the mass distribution, again about the stiffness, about the vertical geometry, regularity in the plans. Okay, we have to reduce the torsional rigidity and whatever the re-entrant corner effect. Again, there should be some rules about the opening into the building, that all should be followed by each and every story for achieving the regularity in the building. And non-parallel system should not, this also becomes one of the irregularity in the structure. Now, next point is about the center of rigidity and center of mass. And after that, we'll see the philosophy of earthquake resistant design. In this lecture only, we'll take this point and we'll stop here for this lecture. And in next lecture, in next week, we'll finish this unit number 3 and we'll continue the next chapter. Okay, so write down the next point, that is the center of rigidity and the center of mass. And you draw this neatly, draw all the diagrams. So you will understand center of rigidity and the center of mass. Wait for 1 minute. Slide is visible to you, Gauri, Suhas?
Yes, ma'am.
About the
Yes, ma'am.
center of mass and the center of rigidity. So what is the center of rigidity? The center of rigidity is a point at a particular story as the location of application of lateral load at that point will not produce rotation of that story. Okay, center of rigidity म्हणजे काय, एखाद्या स्टोरीवरचा जो एखादा पॉइंट जर आपण घेतला तर त्या ठिकाणी due to this application of load of lateral load, so at that point there should not be produced any type of the rotation. So that point is called as a center of rigidity. Center of rigidity म्हणजे काय, it is nothing but it is a story, it is a particular point on a particular story as that location, as the location of the application of load at that point where the rotation will not produce. Rotation त्या ठिकाणी produce झालं नाही पाहिजे अशा ठिकाणचं point which will become on the top of the on the particular story is known as the center of rigidity. Second one is the definition is valid when the slab is modeled as a rigid diaphragm. Simple diagram you draw. Don't draw 3D diagram. Only 2D you draw in your book. You can see this is a red mark and the green color which is shown here as a center of mass and center of rigidity. This is a one of the story you can see, okay, here. And this green portion which is shown as the center of rigidity where the rotation is not firm. And the red color which is shown as the center of mass means this mass is distributed to equally in all the story. And this all the forces are acting here on this story at the center of mass only. Okay, and center of rigidity. What is it? Center of rigidity. So center of rigidity is the point through which the force, if applied, the force is if applied. Okay, so at that point only translation motion is produces. You can see here only the translation motion is produces, not a rotation. For the center of mass, it is showing as a red color where all the forces are they are acting at the center of mass only, but at the center of rigidity there is it is a one particular story, and on which one point is here, and that point the all lateral loads are here, but they will not produce any type of the translation motion when force is acted. Only they produce this translation motion, not a rotation at that point. It is called as a center of rigidity. And center of mass means it is a point where all the forces are acting. So these 2 points in this unit number 1 for deciding the regularity and irregularity. These 2 points about the center of rigidity and the center of mass are very important. And that 2 points also given in your syllabus also. Okay, within 1 minute our meeting will be over. So I request all of you go through the syllabus. Okay, already I have given assignment number 1. Go to the assignment. Try to solve the assignment number 1. Okay. Up to the next lecture, you have to finish the assignment number 1 and try to go for the second assignment. I have not given to you, no? Okay. In next lecture, I will give you the assignment number 2 also. Okay. But try to solve first assignment so we can move for the next assignment. So within 1 minute, our meeting will be over. Thank you all.
Thank you, ma'am.
Okay, try to come for the offline classes. Okay, Gauri, Gayatri, Suhas, Samadhan. Your ISC is scheduled soon. ISC.